class you ever take forever. So let's take a look at them now. And again, you'll notice that I've used 2-column notes, which is a way to organize your notes that you might like to try. On the left-hand side, I've got the main idea, and then I'm going to put the details on the right-hand side. First one I want to look at is commutative. In the commutative property, it is just so simple. And I know when I was learning this in school, I thought it was just silly. I just thought, why do you have to call this something? And it's really hard to say that right now, but it's really when you get in higher math and you want to get deeper understandings that you need to know that you have permission and that you really understand what these properties mean. For example, the commutative property, you have two of them. You have one commutative property of multiplication, and then you have a commutative property of addition. So the commutative property of multiplication says that you can take any two numbers and multiply them, and you'll get the same thing no matter which one you put first. So whether I put 4 times 3, or whether I put 3 times 4, I'm going to get 12. Duh, of course. But that's really all that that property says. So in algebra, it's saying it doesn't really matter whether I put x times y or whether I put y times x. The order doesn't matter, it's the same. It says that when you are multiplying two quantities, the order doesn't matter. It doesn't. 2 times 3 is the same as 3 times 2. Now if you were dividing, think about this. 8 divided by 4 is 2, right? But 4 divided by 8 is not 2. 4 divided by 8 is 1/2. So this is not like true for everything. It's only true for when you multiply and when you add. So if you were adding, you would be saying something like, maybe you're going to add 4 and 1, or whether you added 1 and 4. You're going to get 5 both ways. So it doesn't matter which one comes first. So over here in our algebra example, we could say, if we were adding, say, 3 plus x, it would be perfectly all right. See, it really gives us permission to change things around sometimes when we need to. It'd be perfectly all right to put the x first and go x plus 3, because we're saying that they're the same thing, and it doesn't matter in multiplying and adding two different numbers or variables. It doesn't matter which one we put first. That's what it's saying. In adding and in multiplication. So that's called the commutative property of multiplication. When we're looking at the one called associative, and again we've got an associative of multiplying and we've got associative property of adding. And it's very similar, but it's not exactly the same thing. Remember now, the commutative property said when you multiply two things, two terms, two numbers, two variables, or when you add two, you can go either way. You can go this way or that way, and they're still the same when you're multiplying or adding two. But associative, so this is about the order of two quantities. And a lot of people like to say commutative is about order. Order doesn't matter when you multiply or add. Associative is about three quantities. And what it's saying is, hey, gang, if you're in arithmetic, I'll just start there. If you want to add 2 and 3 and 1, now we're adding 3 terms together, 3 numbers. It doesn't matter. I told you your brain just learn. It really takes 2 numbers at a time anyway, whether you're aware of it or not. It does. So what it's saying is it doesn't matter which 2 it takes first. If you're adding and multiplying, it really doesn't matter. It does matter in dividing and subtracting, but it doesn't matter in multiplying and adding. So you get to change things around a lot. So in associative, it says you can add the 2 and the 3 first. That's why the parentheses are there. It's like, hey, do me first. Or I could keep them in the same order, and I could add the 3 and the 1 first. Obviously, I'm going to get the same thing. 2, 3, 1, 2, 3, 1. It's the same numbers. But here I have grouped the 2 and the 3 together, and here I have grouped the 3 and the 1 together. And you might be saying, as I always did for many years, that is so obvious. Why do I have to learn that? It is obvious. You were born knowing it almost. But you weren't born knowing the name of it. So let's just have a name that we can refer to. So when we need to say associative, we're all on the same page and we know what we're talking about. It's really talking about grouping. So let's put that word, grouping. It says if you're adding or multiplying 3 numbers, variables, terms, whatever, you can choose any 2 of them to do first. I don't just have to do the first 2. I could do the last 2. I could do the 3 and the 1. I'm going to get the same thing. 3 and 2 is 5 and 1 is 6. 3 and 1 is 4 and 2 is 6. I'm going to get the same thing. If I see that kind of thing in algebra sometime, it might be that I see x plus y together and then w. And then later in the problem, or on the next page or the next day, I might see x and then I might see y and w grouped together. And so it's saying it doesn't really matter. I've got the order the same, x plus y plus w, x plus y plus w, because this one's about order. Commutative is. And associative says I can associate these 2 together, the x and the y, or I can group these 2 together, the y and the w, and it does not matter. Because in the end, I'm going to be adding all 3 of them anyway. And the same is true about multiplying. So whether I multiplied 2 times 3 together and got 6, and then times 1, and I still get 6, or whether I decided to multiply the 3 and the 1 together first and get 3, and then 3 times 2 and get 6, it doesn't make any difference. I can group whichever 2 I want to group anytime I have 3 terms that I'm adding or multiplying together. So an algebraic example would be, and you'll see this a lot in your books, and I just always didn't even want to look at it because I just thought it was so obvious to me, or pointless, maybe that was a better word, but it isn't. So trust me on that. A times B, I can group the A and the B together, or I can say, hey, I had rather group the B and the C together. And way down the line one day, we're going to do something like that, and I'm going to ask you, why can you do that? Why are you able to do that? And you're going to say, oh, I'm able to do it because it's the associative property. I'll say, oh, okay, good, you can do that then. Okay, the next one is distributive, and this is usually everybody's favorite. Distributive, and you have distributives with positive and with negative, but distributive is this one. Remember when we had these kind of multiply? And we took the number that was outside and we multiplied it by everything that was inside. So we went 2 times 4x and got 8x, and then 2 times 1 and we got 2. Yeah, remember that? We just had parentheses and then we removed them by multiplying. That's the distributive property. We could do that without having a name for it, but that is a name that you'll find yourself using a lot. It just makes it easier than explaining something in a long sentence if you can just say, oh, it's distributive. And that's what we'll be doing. Okay, here's another one. I could have I could have negative 4, let's do that, and then I could have 2x plus 3y minus 1. Because I can have lots of things, lots of terms in the parentheses. It just says whatever is outside the parentheses, you multiply by it all the way through. You distribute it all the way through. So we do that and we get negative 8x, because you know that a negative times a positive is negative. I know you know that. You promised me you would know that. And then a negative times a positive is negative. 4 times 3 is 12, and that would be 12y. Negative times a negative is a positive. 4 times 1 is 4. So I've got parentheses, now I don't. I've removed them. I've removed the parentheses and made it more simple by distributing, by using the distributive property. So let's check that again. So we've got negative 8x, we've got negative 12y, and we've got positive 4. I could also have something in a case where I would have 5x minus 2, and I would have the number that I was going to distribute or multiply by. I could have it on the back, and that wouldn't matter. I would do the same thing. I would say 4 times 5x is 20x, and 4 times negative 2 is negative 8. So it is still the distributive property, and that really tends to be most of my students' favorite. Okay, now I want to look at the identity. If I say, are any of you out there identical twins? There probably are some of you who are identical twins. I always have some identical twins. And that just means that you're identical, you're just alike. Of course, you're not really. I'm stretching a point, I'm just making a point. But if two numbers are identically the same, then we know what that means. There's 4 and then there's 4. Okay, so identity means if you have a number, we'll use 4, and you multiply it by 1, then you're going to get identically the same number that you started with. There's no other number that you can multiply except 1 where you will get identically the same thing you started with. Even if you turn it around and use the commutative property and you go 1 times 4 and you get 4, if you multiply by 1, you will get identically the same thing. Of course, and yes, you're saying this is so obvious. It's so obvious, but we need to call it something. That's all this is about. So whenever what you start with and what you end with are identically the same thing, then you have used an identity property. So I've used an identity property here, and I've used an identity property here. Just turn it around, really. Here's another way, that's multiplying. So let's look at how an identity property looks in adding or subtracting. Let's suppose that we have 7. And then I add a -7 to that. I'm going to change my mind on that one. That's not what I want to do quite yet. So let's just hold on here. Excuse me for that. If I have 7 and I add a 0 to it, then I am going to get identically the same thing I started with, of course. And again, that's a 0 property. It's an identity property. If I call it 0 property, you would know that if you add 0 to something, you get the same thing. But I want you to know what identity property means, because you'll see that a lot. So identity property means always that what you start with on the left, the value of the left, whatever you've done to it, has not changed the value of the same identical value on the right side. So even if you have 0 plus 3 is equal to 3, the value of the left side is 3, the value of the right side is 3. You added something to it, and yet you didn't change the value. You got identically the same thing. That's your identity property. It makes good sense, doesn't it? Identical twins. You've got identical things, identical values on both sides. Identity property. I'll say it lots of times. Grasp what you can from this right now. I'll say this a lot of times during all of our classes if you take other classes with me, and so it will become very, very easy for you before you're done. Inverse. Inverse is whenever you cancel. I'm just going to make it easy. There are a lot of ways to explain inverse. I can say it's the opposite, or I can say it's the reciprocal and such, but I'm just going to say it's like this. If I have 8 and then I add a -8 to it, then I could just say 8 and -8 cancel each other. They do. +8 and -8 cancel each other. So if I cancel +8 and -8 and I get 0, it's really not about what I get, it's about when I cancel. If I cancel, then it's inverse. It's called the inverse property. So when I add something to its opposite, like I add -8 to +8, that's the inverse property. I just find it easier, and so do my students, if they just think of it as whenever you cancel, it's inverse. Cancel, it's inverse. Fancier name, a little more sophisticated name for it. If you have 3/4 and you're going to multiply that by 4/3, and you cancel, because we haven't talked a lot about this, but you can cancel any bottom and any top. And so if you cancel whenever you're multiplying, you can. So if I cancel the 4 and the 4 right here, and then I cancel the 3 and the 3, and everything cancels away, and I have 1. If I cancel, go whoosh whoosh, draw those lines through, it's the inverse property. I think that's the easiest way to learn it. I'll say it other ways as we go through, but let's just start with that way. Of course, you could have gone 3 times 4 is 12, multiply across the bottom. 3 times 4 is 12. And you could have canceled right there. Wherever you cancel, if you cancel, either in multiplying and dividing or in addition, subtraction, you're using opposite operations and you're canceling things out, you're using the inverse property. So hopefully over time you'll get to where you know these properties really well. I know you've heard of them. I know that you've done this before, but I have an awful lot of people who come to me and they could write this down, but they don't understand it. They can't apply it in problems, and I'm sure that you can. After you study it a little bit, after you work with it, download the sheet that I've given you, and I've given you several levels of problem difficulties. And start with the easiest. Master that always before you go to level 2. It's like in your video games, you know. You got to pass level 1 really well before you ever get to level 2. So practice it and work on it and master what you can, but don't worry if this runs together or you forget or whatever, because we will talk about it so much together. Don't take it for granted. I expect you to work on it, but we will keep working on this together. So properties are in geometry, big time. They're in Algebra 2, they're everywhere. So the sooner you get really comfortable with them and you know them really well and you understand them, the better for you. So I hope that just makes your day, and it does mine. So have a great one, and I'll see you next time.